Hello, my name's Art Dula. I'm an attorney in Houston, Texas, and I'm going to talk to you for a few minutes as an introduction, and then we're going to have a little presentation on commercial space activities, what's happened, what is happening, and what might happen in the future. I've been an attorney for about 40 years now, and almost all of my work has been in high technology aerospace. I was founder of the company that launched the first private spacecraft from Matagorda Island in Texas. I actually organized that company, and I also formed the company that bought the first Russian rockets to launch American satellites. I've worked extensively with the Chinese and the European and Russian space programs. And my specialization is inventions that have to do with aerospace, and preferably things that are on the cutting edge. So why don't we get going a little bit? I'll bring up a PowerPoint presentation, and I'll try to make it attractive. There we go. Now, you'll notice that this does not say LibertyCon, and that's deliberate, because for the past year, since the ending of 2019, there really haven't been any space conferences. But in 2019, in November, late November, I was in Wuhan, China, at the invitation of the Chinese commercial space group, and I was giving a talk on American commercial space. And just before that, a week before that, I'd been in Luxembourg working with my colleagues there and giving presentations on commercial space in Europe and America, having to do with the Luxembourg movement toward space mining. I think you probably all know about that, but they did invest 200 million euros, and they wanted to get an investment from private sources of 1 trillion, not trillion, billion, sorry, euros. And then I took some of that presentation and the presentations that were made by the Europeans and took them to China to get the Chinese view. While I was there, a number of people I know in the Chinese Society of Astronautics asked me if I would address a legal conference called the East Lake International Law Forum. This is held every few years in China, and it's their top legal forum looking at technology in the future. And they wanted me to talk about space more generally. And I was very honored to do that. But I note that I was in Wuhan, China, when the pandemic broke out there. Of course, nobody knew about it. But I got home in February, and shortly after that, you know what happened. Now, I'm an academician in the International Academy of Astronautics. This is a group of experts from all over the world in all areas of technology, social sciences, and law that meet and plan for the future. They also do studies to help guide and inform. So why don't I go through what I told the Chinese? It's still current. To the extent that it's not current, at the end of this talk, I'll update you on the Artemis Accords, which are the attempt by NASA to gain an international consensus that is in favor of liberty and free enterprise. I think you'll find that conclusion worth waiting the entire presentation. So let's go. Let me see if I can operate this thing. And I apologize in advance, because this is the first time I've ever given a virtual presentation. I'm learning, and I hope that you will forgive me for any slips or slides. This is a vision of the future from the 1930s. And it's a Russian movie. By the way, it's a very good one, surprisingly, even though one of the big spacecraft is named Vladimir Lenin. But if you want to see how the Russians were thinking about the future in the 1930s, you might want to look at this. The point I'm trying to make is that we've been trying to look into space for a long time. And we still only have about 7 or 8 people up there. So have fun watching the movie. And it would be wise for us to remember history, because we have settled a new world before, at least Europeans have. So the European ascendancy during the 15th and 16th century was triggered by economic forces. And by looking at economic forces, sometimes you can, through a glass darkly, see some of what the future might be like. So let's look back to 1421 through 1520. Well, the first large voyages of exploration were done by Zheng He, who was a Muslim eunuch in the employ of the first emperor of China that united all of China, who built the Forbidden City and started the Great Wall. He did voyages of exploration for political reasons primarily. He had an unlimited budget from the emperor, at least initially. And the political reasons had to do with internal politics in China. I'll let you do the Googling on that, but let's just say that he wasn't really interested in trade, but just in perhaps bringing back some tribute for the emperor. And the ships that he constructed in Nanjing were much bigger than the ships used by Europeans. Here's a picture, a drawing of the largest of the treasure fleet ships from China in 1421, and the largest ship in the 3-ship flotilla for Christopher Columbus. As you can see, the Chinese ship is much bigger. Also, the Chinese had hundreds of ships, not all this big, but they certainly had dozens that were this big. Then we had Christopher Columbus, and this was from about 50 years later, 50 years after the Chinese. And he was an entrepreneur. He wanted to take and find spices so he could sell them. He initially went to the east, but the problem was that the Arabs, where now there's the United Arab Emirates, had that market, and they weren't going to let Christopher Columbus into it. So he thought as a young man that he could go west. He knew the world was round. Some people think he even had maps. And by the way, there's some opinion that the Chinese treasure fleet actually went around the world, and there's good evidence, even genetic evidence, that it got as far as Italy prior to the Renaissance. And some of Leonardo da Vinci's sketches are virtually identical to the drawings in the Great Chinese Technical Encyclopedia that the Chinese treasure fleet took with it to encourage trade and to inform people. Again, they weren't primarily interested in money, but Columbus was definitely interested in money. He had a company called the Enterprise of the Indies, and he financed about half of it out of his own family and friends, but he didn't have enough money to get ships, and that's why he first went to Spain, first went to Portugal to Prince Henry the Navigator, and the experts in the School of Navigation told the Portuguese ruler that there was no conceivable way that Columbus's ships could go around the world. They knew the world was round, but they also knew how big it was. and they knew the capability of Columbus's ships. And they were absolutely correct. What they didn't know was that North America or South America existed. So he then went to a country, Spain, that didn't have much knowledge about doing what he wanted to do, that didn't have that board of experts. And he finally, after years, managed to get 3 ships. And those ships, by the way, were seized by the crown for smuggling. So he managed to get a couple of small ships, 3 of them, and he made his voyage of discovery. And we know about that because we study history. By the way, Columbus never thought that he'd ever gone to another continent. He thought he was in Japan to the end of his life. He never admitted that he didn't get to Asia. Now, this woodcut in 1493 is the first pictorial depiction in Europe of the voyage of Columbus. You can see the 3 ships, you can see the natives, you can see the king saying, go ahead, take the ships, go. But if you were in Europe in 1493, this is the picture you would have seen about Columbus's first voyage. Now, I'm a lawyer, I'm interested in economics and economic motivations. And so you might like to know what the business arrangements were between the King of Spain and Columbus, the enterprise of the Indies. This is a translation from the Latin of the contract between the King of Spain and Columbus. It was entered into on April 17th, 1492. And you can read it on your screen. I won't read it to you. But the point is, the king got 90%. Columbus got 10%, plus some fancy titles. Admiral of the Ocean Sea. I might mention that the King of Spain never paid anything on this contract. And the family of Christopher Columbus litigated this for a very long time with the crown, but they never got anything. And furthermore, this is twice as much as the king normally gave to anyone, 10%. Normally, the king took 95%. But I don't think the king actually believed that he would ever see Christopher Columbus again. Just my opinion. Now, the year after Columbus's discovery, Pope Alexander VI, in 1493 in May, issued a proclamation, a papal bull, granting official ownership of the entire New World to Ferdinand and Isabella, the monarchs ruling Spain. And you can read the language as to what he gave them. And he gave them everything, absolute everything, absolute power in them, and no recognition of any existing people. Just as a sidebar, I'll mention that the diseases brought by Columbus quite unintentionally probably wiped out 95% of the humans that were in North America before there was any significant settlement. So that was the equivalent of a major genocide. And you can read about that. It's pretty well accepted now. But the point is that I'm trying to make is that the Pope, which was the leading authority on earth, I mean, the kings of Catholic countries derived their power by grant of the Pope, technically, gave the entire New World to Ferdinand and Isabella of Spain. Well, Portugal didn't like that. And so there was a dispute between Spain and Portugal. And in 1494, the Treaty of Torto, I don't remember how to pronounce the name, but it was the treaty that divided the New World between Spain and Portugal, 2 Catholic countries. And by the way, that's why Brazil speaks Portuguese today and the rest of South America speaks Spanish. And that was negotiated back and forth for a few years, but it didn't take into account England. because England was not a Catholic country. And as a result, England set up commercial activities and had issued letters of marque and reprisal and sent private parties out to settle the New World. And you're probably familiar with that history. Then in March of 1518, just 10, 15 years, 20 years after Columbus, a soldier of fortune approached King Charles of Spain and asked if he could have a contract to go around the world to get spices. And, well, he got the contract. The contract was that he would receive 1/20th of all profits, and the crown would get 95%. So it was back, they knew about the New World now, so the king wasn't willing to give the good 10% deal. He only got 5%. But the heirs of Magellan would gain the government of any lands they discovered. So he set out with about 250 people in 5 ships. And a couple of years later, in 1522, one ship got back to Spain, and it had only 18 people left alive on it out of the 200. So he lost 80% of his ships and over 95% of his crew. And yet the expedition made a profit, or at least broke even, from the spices in the whole of that one ship. Now, it's said that those 18 people got on their knees to get off the ship and walked on their knees to the nearest cathedral, where they gave praise to God that they'd gotten home. And the story of Magellan's voyage around the world is a great epic, and you should definitely read it. It's instructive to the modern age. But can you imagine NASA or ESA or Roscosmos or JAXA giving permission for a voyage where you were going to lose 80% of your hardware and 95% of your crew, even if it yielded a profit from space mining? I can't imagine that that would ever be allowed. But yet this one voyage around the world set off the European ascendancy for the next 2 centuries that made Britain the master of the British Empire and made Europe the leading economic and political power in the world. So you can't always guess what's going to happen. So in summary, in case you're taking notes, Zheng He, 1405, 1433, he had between 48 and 300 odd ships, 28,000 crew, and it was a non-profit government program. He failed totally. The ships couldn't be operated without an imperial budget. The Mongols attacked, and the budget had to be used to fight off the invaders. So it was necessary for national defense purposes. And by the way, this is the reason that the last 3 Apollo missions were canceled, was because the money was needed for the Vietnam War. So the Saturn V rockets at the Johnson, Marshall, and Florida Space Center, they're real moon rockets that just didn't get to fly. Columbus, 1492, and China was the leading country in the world then. They had all the technology, they had all the money, they could have easily conquered Europe. But they just stopped. They stopped. Columbus, several human generations later, had 3 ships with 90 crew. It was a commercial program, and it was successful. Magellan, 20 years later, had 5 ships, 265 crew. It was not only a commercial program, it was a success, and it set off a chain of activities that increased the wealth of Europe the people that undertook it, and England, enormously. But you can say that that's ancient history. So let's look at the invention of something more modern, like, say, an airplane. Well, first of all, it is a commercial activity now. I think everybody would admit that. It became $1 trillion world industry in just 1 century. 100 years it went from the first powered flight, to being $1 trillion a year industry. Now, nobody saw it coming. I've got a couple of examples here. No one sees the future coming. The telephone has too many shortcomings to be seriously considered. That's a Western Union, the leading technology company, in 1878. A similar report came from the British Post Office, which handles their telegraph. And they said it was perhaps useful, the telephone was perhaps useful in America, but in Great Britain, they had an adequate supply of messenger boys, therefore they did not require it. At the same time, one of the greatest scientists that ever lived, Lord Kelvin, Kelvin temperature scales named after him, stated that heavier than air flying machines are impossible. Not just difficult, not just it will take longer, they're impossible. So, Mr. Robert Heinlein, who I'm proud to say I'm the literary executor for Mr. Heinlein's estate, and I like his writing a lot, said always listen to experts. They'll tell you what can't be done and why it can't be done, and then you should go do it. And that can't be stressed too much. Even if it's against the laws of physics, nature, man, and God, it may be that you can still do it, because it might be that you were wrong about it being impossible. Okay, case in point. This man is Samuel Langley. The NASA Langley Center is named after him. He was the leading aerospace person in 1900 to 1903 or 4. And Samuel Langley was trying to build what he called an aerodrome. Now here's a picture of what he thought he was trying to build. It's an airplane. And he had the backing of the US War Department. He had the largest grant of money that the US War Department had ever given to anyone for science. He had the backing of the universities on the East Coast of the United States. He had the backing of the Smithsonian Institution. And every time he tried to fly his aerodrome, this is what happened. And this is all he was left with. So he didn't think he could succeed. He thought it might be impossible. The Lord Kelvin might be right. In the meantime, 2 brothers, I think you know who these guys are. They're the Wright brothers, Orville and Wilbur. And they had a little bicycle shop. Here's the bicycle shop. This is actually their bicycle shop, by the way. And they had families. One of them had a high school education. The other didn't. But they wanted to build an airplane. Obviously, if Samuel Langley couldn't do it with all the money and backing, prestige, and knowledge, they certainly couldn't do it, because they had to make a living. They could only work on this in their spare time or on their summer vacation. So they built this. And we know where that went. It turned into 747s and SR-71s. The wonderful thing is that somebody had a movie camera when they, on their summer vacation in South Carolina, took and flew the first powered flight. And so now it's 2019 when I put this presentation together. Let's look at the economy. Since we've kind of shown that nothing's impossible, and that people that we really wouldn't think could do anything might be able to change the world. That means you can change it, by the way. Let's look at what the current economy of the world is. Well, you can read this chart for yourself. The United States has about a quarter of the world's economy, Europe a little less, all of Asia maybe a little more. And the point is that the world economy is at about $75 trillion now. $75 trillion. And there's about, what, 8.5 billion people? So that translates to about $10,000 per person. Of course, it's not distributed that way. But I wanted you to look at this to get an idea of what the envelope is for the future. In other words, we have this much money, this large an economic product to work with, to drive everything. And we have population, of course. The population's leveling off. We're catching up with almost all countries becoming middle class now. Hardly anybody has no access to medical care or no access to education. There is not any large amount of starvation in the world. The world is much better off than it was. But this graph from 1750 to 2150 shows that the developing world, I don't like that term, the world that is now middle class is growing far faster than the rich world, which you could call the developed world. The rich world is only about 15%. It's the United States, Canada, Europe, Japan, Australia, a few others, about 15% of the world's population. The rest, they don't live as well. They still live very much better than they did 50 years ago. This is the workforce that you have to work with if you're going to move the human race into space, if we're going to believe that. Now, this chart's going to take some explanation, and then I'll get into some more good stuff. But pay attention. If you look at this at the year 1700, China and India and Western Europe each had about 1/3 of the world's wealth. And prior to that, India and China had all the wealth. India or China could have easily discovered North America. They could have had the expansion in technology and wealth that Europe had. But instead, they gave up because they only had government programs. They didn't have commercial programs. And as a result, between 1700 and about 1820 to 1900, they declined very rapidly, and Western Europe became ascendant. I call this the European ascendancy. And the United States, which was an offshoot of Europe, came up and very rapidly. Now, please look over at 2008, which is the latest that I had data for on this. And you'll see that we're back in that situation where only 3 groups have all the wealth on the planet: the United States, Western Europe, and China. Now, if I could project this to 2200, I can't. It's not possible. Too many decisions of time and place have to be made. But you can see that we're at a crux, just like we're at a crux in 1700, when China decided not to build a navy and Britain decided that they had to build a navy. And we know what came from that. But even though the population during that period of time grew over 700%, the gross world product grew 48,000%. So the average for the world population went up by about a factor of 10. And it's still going up, and it's still going to go up. So here's the world GDP per person. This is in standard $1990. I'm not playing funny with the numbers. These are all the same dollars. You can see how much richer the whole world is getting. Now, let's just take a quick look at how it's shared. 68% have 3% of the world's population. Less than 1% has 41% of the world's population. Not population, money. wealth. You can say this is good, you can say this is bad. It's the way things are. Now, let's switch from the general overview that was to give you situational awareness, and let's talk about space economy. Here's a chart that shows the space economy as of a few years ago. And it's about $300 billion. If I went back a decade, it would be less than $100 billion. But now it's about 300, and this year it's probably around 400. Now, when you say space, you have to get into space to do anything. This is a chart that shows every launch that's occurred off the Earth. And you'll notice that up to the 1990s, the Soviet Union was the principal launcher of everything. The United States picked up some during the 60s for the Apollo program, and then the space shuttle started running. But look to the lower right, and you'll see the commercial launch providers. And if I had the 2021 statistics for this graph that was done by The Economist, I assure you the commercial launch providers would be much larger because just SpaceX is doing so much more. And as soon as Jeff Bezos gets his New Glenn running, I think we'll have what's called competition. And all of these vehicles will be reusable. And then hopefully Elon Musk will get his Starship running, and that'll carry about 3 times what the Falcon Heavy or the New Glenn will carry, and it's 100% reusable. Well, NASA thinks well enough of it that they've given a $92 million contract to SpaceX to put the next Americans on the moon. They'll fly them out there on the Orion capsule and then transfer to because the Orion capsule can't land, it has to dock with something. It'll dock with the Starship, the crew will transfer, and then the Starship will land on the moon. Why is this happening, and what's going to happen for the future? Let's look again at capabilities. What countries graduate the most people in science, technology, engineering, mathematics? This is a few years old, it's from 2016. China and India. And the Indian population is much younger than the Chinese population, so we can expect India to outpace China within the next 20 to 30 years. And the US and Russia are next. Then, surprisingly, Iran, which has the capability to become a major space power. This tells the future, because these people are the people who will build it. And I bet that hardly anybody knew these statistics. They're interesting. It's a good reason to take and try and not have conflicts so that we have the ability to use all of these people to help us become a spacefaring race. And what's the space budget of the various countries now? Well, the USA is just out in front by a mile. The USA spends much more than any other country on space. And the US really has 3 space programs. But we'll get to that a little later. The NASA budget is just without parallel, frankly. And this year it's bigger. This is the national budget adjusted for inflation of NASA. And you'll notice that for 40 years, since 1980, they've had roughly $20 billion a year in current US dollars to build a space program. And they have 7 people in orbit. And some of those are not Americans. I would have thought that we'd have at least 2 or 3 million people in Lunar City by this time, and they'd be self-sustaining. But such did not happen. My point here is that the NASA budget after the peak of Apollo has been relatively stable. Okay, and this is their budget request. They're actually going to get more than this, but this was the future projection for 21 and 22. The United Launch Alliance made an economic study of what they call the cislunar 1000 economy, that what will happen by the time you have 1,000 people in the space between the Earth and the Moon, the cislunar environment. And it was their opinion that within 30 years, we'd go from 300 billion a year to 3 trillion a year, increasing by a factor of 10. Now, I know the people that did this study, participated in it. And I can tell you it is unbelievably conservative. As soon as we have inexpensive access to space, and we don't have that yet, we'll be able to do a lot of things we can't do now. The problem is one of activation energy. It takes an awful lot of wealth to get everything started to where you have enough people up there to have a self-sustaining economy. Okay, now, the last major European space conference was in 2019 that was held in person. There may have been some virtual ones since then. Here is the China Space Foundation look at private investment. This is what they disclose as private capital in China going into commercial space. And it exceeded 10 billion yuan. And we're starting to see the results from it. It'll be a few more years before we see the Chinese on the moon, before we see them build something as big as a Starship. They've announced that, by the way. The Chinese space program has announced a ship that would have the same capability as the Starship, would be completely reusable, and from the outside looks exactly like the Starship. Now, not just China, but global venture capital investment has mainly been in data and in launch services. And you're looking at several $billion a year up through 18. And in 19, 20, and 21, those numbers got a lot bigger. They're starting to attract mainstream investment. Remember, the US has a $17 trillion, a $20 trillion economy. So this is actually down in the noise. It's not a huge major investment, but it will become so because it's one of the few things that you can plug a lot of money into now and still get a real significant return on investment. By the way, this plugging large amounts of venture capital into things and not getting money back is characteristic of the end time of a long economic cycle that begins a new cycle where you have new investment with really big return on even small investments. So we're in this time of ebullience between the end of one economic cycle, the government cycle for space, and the new cycle, which is the commercial use of space. And here's Europe's share in the global venture capital market. The size of the average deal, total amount for 1918, again, these are going up rapidly. And the average round size for a Series B is up to about $40 million now in 2019. Again, this isn't data for 2020, I don't have it. And who invested in what stage? Now I've got to talk to you a little bit about space law. I have to, because for you to understand the rest of the presentation, and I'm approximately 45 minutes into it now, so we have an hour to go. You wonderful people being patient and listening to me talk about economics and all of this. And you say, well, where's it going on space commerce? I'll get to it. In order to take and have space commerce, you must have space law. We have plenty of money. Why do I say that? Well, banks have a product. The product of a bank is money expressed as loans. And the money the bank pays for the money that it sells in loans is called the interest that it pays on deposits. And the interest being paid on deposits right now is at a historic low. For some banks in Europe, it's negative. You actually have to pay the bank to keep your money. Now, I realize that in the long term, there will be inflation. The demand for money will outstrip the supply. But right now, the world is awash in capital that has nowhere to go because they don't know whether they can make money on the investment. Space offers the opportunity to take an almost infinite amount of capital investment and still pay good ROIs, return on investment. So I've got to give you a little brief on space law. I taught this for 30 years at the University of Houston. Whoops, what's happening there? Something's happening. Sorry, I pressed the wrong button in my excitement. And remember, I gave this presentation to the Chinese so that they'd understand how our law worked, because they don't. Their law, they're a tyranny, and they have good lawyers, but they don't have a good rule of law. That's just my personal opinion. I like the Chinese, they're a wonderful culture, but it would be nice for them to run according to the rule of law. These are the sources of space law: traditional law, international treaties, international agreements, national laws, national regulations, and national policy. Also state law. There's an interesting conflict now between state law and national law as to insurance and damages during the launch of a private space vehicle. State law may control on the ground, and federal law may control up and down to space and from space, and state law may control in orbit because there isn't any federal law. This will all be explained in far better detail in the talk on space law that's coming up in this conference, where we have an excellent space lawyer from Washington talking about it. I'll be there too, but she will do most of the presentation. So let's look at these just really briefly to get a situational awareness of what do you have to comply with. Okay, international law is, well, originally there wasn't any international law for space. Under Roman law, the law extended up to the sphere of the fixed stars and down to hell. But once we had the airplane, we had to determine where national sovereignty began and ended. And the First World War made that pretty important because people dropped things from airplanes and mounted machine guns on them. So in the 1920s, there was a meeting by the nations, and there was a international convention on air navigation, and it was determined that every country owned the airspace above it. But again, it owned up to the stars. There was no upper limit on the ownership of airspace. Then, Sputnik was launched in 1957 on October 4th, and all of a sudden, that was an invasion of American airspace. But instead of reacting badly, the United States, somewhat frightenedly, got into the space race. And pretty soon there were satellites flying all around the Earth, and there was an ordinary common principle of law, traditional law, that said you had a right of overflight at some altitude. By the way, there's still a disagreement about what altitude that is. The US Air Force recognizes 50 miles. Everybody else recognizes 66 miles. In the early 1960s, when the US didn't have much of a space program, we hadn't succeeded very much in the late 50s and early 60s, and the Soviet Union was getting success after success, the US became concerned that Russia would claim the moon for the Soviet Union. They had good reason to be worried about that. The Soviets wanted to keep private enterprise out of space. And so they formed a great compromise. It was a Faustian compromise. It's horrible law that the U.S. Would require authorization and continuing supervision of all private activities in outer space and would bear international responsibility for them as a state. By the way, there's nothing else that requires that. And the Soviet Union agreed that there would be no claim of national sovereignty on a celestial body. And everything else is kind of details. The treaty recognizes that you can use outer space, and use is a very broad term. It includes commercial use, it includes economic use, however much some countries wouldn't like to admit that. In any case, the Faustian Compromise worked, and it was put into place by a United Nations committee, a rather small committee for the peaceful use of outer space. And there was one main treaty, the Outer Space Treaty of 1967. And then there were 4 more treaties that derived from paragraphs in that first treaty. A rescue and return agreement just before the moon flight by the US, so that if Apollo landed somewhere we didn't want it to, we'd get the astronauts back. A convention for damage done by space objects, which is a complicated treaty, and it's never been used ever. Since 1972, not a single claim has been paid. A registration convention, everybody registers their objects and their national law applies to them. And finally, a moon agreement, which essentially would have extended socialist law to the entire solar system, and it would have prohibited development, according to some legal scholars. At any rate, it has not been widely adopted and is generally considered to be a failed treaty. And then there are some United Nations non-binding resolutions that are very persuasive for national law, particularly on remote sensing and the role of national law. Now, these treaties, you have to look at the Vienna Convention on the Law of Treaties. Basically, if enough nation states accede to a treaty, it can be considered customary international law and binding on non-parties. But the United States has not ratified the Vienna Convention, but still is guided by it. And then we have international agreements on the space station and multilateral and bilateral agreements on many things. There are hundreds of international agreements. The most important one is the international agreement on the space station. And in the US, there's a hierarchy of laws, and this is not true everywhere in the world. In some parts of the world, a treaty is the supreme law of the land. But in the United States, the US Constitution is the supreme law, and treaties and federal statutes are co-equal under it. And under that, there's administrative and common law, and then state law. The important thing to recognize is that a US federal statute can overrule a treaty in the United States. And no treaty can be self-executing if it's against the US Constitution. Now, let's talk about that Constitution. There's one amendment that's particularly important. It's the 10th Amendment. It reserves power to the states and the people. I'm going to read it. The powers not delegated to the United States by the Constitution, nor prohibited by it to the states, are reserved to the states respectively or to the people. This is radically different than the codal law of most of the rest of the world, where the law is the supreme will of the legislature. For example, Great Britain doesn't even have a written constitution, and the civil codes of most of Europe are derived from the laws of the later Roman Empire, which was not known for democracy. So the important takeaway here is that the US government only has delegated powers. It doesn't have general powers without delegation from the Constitution, or it's a government of delegated powers, not of universal powers. It's different from Britain or from Europe or from Japan or from the socialist laws of Russia or the communist laws of China. Okay. The 10th Amendment was written to emphasize the limited nature of the powers delegated to the federal government. For example, there is no federal law of marriage. And that has come up in spaceflight. There was actually a marriage performed by radio. And the question was it legal? It was in Texas. So finally, it was put on the register here. Okay, and here's your hierarchy of federal statutes: the NASA Act, the Commercial Space Acts, the FCC and FAA Acts for specific things, and so on. We'll get into this much more in the space law presentation. State and local law. We had wrongful death claims for astronauts. Contracts and torts are almost always state laws in the United States, actions for those. And there just really isn't any national corporate law. A corporation is always incorporated in a particular state. So when you talk about a US corporation, you're really being imprecise. You should say a Delaware corporation or a Texas corporation. And the rights and obligations are quite different. Okay, now I'm going to talk now. I've got about 50 minutes left about the 3 US space programs and what they're going to do and what they have done, what they'll do in the future, and why. The best part of this presentation is toward the end, so please don't sign off. We have 3 space programs in the United States. There's a civil space program run by NASA, civil government space program run by NASA, about $20 billion a year. It's been going on for decades. We have a military space program, which is the Department of Defense. CIA has a space program, the NRO, National Reconnaissance Office. This is all of the national security things. And that budget is at least as big as the civil space budget, but we don't know what it is because you can't really look it up. And finally, we have a beginnings of a commercial space program. This is all the new companies that are starting to launch and doing things. We have companies that are going to build private space stations. We have companies that are going to take and build private rockets. Some have built and pretty successfully. And there would be many, many more. When airplanes started to fly, there were thousands of different airplane designs. And I one time researched how many people were killed trying to fly those early airplanes. And when I got to over 500 people, I quit the research. You can't go forward without risk. It's just impossible. And managing that risk in the light of CNN and all the attention to things that are dramatic in our society is difficult. Right now, the FAA handles licensing, but does not control the industry. The FAA, and again, the panel on space law will go into this in detail, licenses launches, licenses reentries, and licenses spaceports, and has sets of rules where they allow individuals for manned spaceflight or crewed spaceflight to accept the risk, just like they do when they climb Mount Everest or they go diving in a cave underwater. And the commercial sector was created in the early 1980s with the passage of the Space Launch Act. When I set up Space Services Incorporated and we launched the first private space vehicle from Texas, this act didn't exist. So there was no federal law. And believe me, everybody was interested in regulating what we were doing, and none of them had jurisdiction because they didn't have delegated powers. So that was interesting. And now there's a tension now between the Department of Commerce and the FAA as to who is going to control actions in space. In other words, who's going to control the actual activities in space? If you want to get up there and set up a hotel, are you going to be licensed by the state of New Jersey? Or are you going to be licensed by the FAA? Or are you going to be licensed by the Department of Commerce? That simply hasn't been determined yet. We're still developing those laws. Now, originally, this sector was under the jurisdiction of the Office of Commercial Space Transportation and the Department of Transportation. But now it's under the FAA. Okay, let's move on. And this is just policy, to talk about what the policy is. And if you look at I don't have Trump's policy in here for the simple reason that this presentation was written prior to it. But Trump's policy was very pro-commercial space activities. And he put out 4 different policy documents as executive orders. And he also appointed a very pro-commercial National Space Council. And all of that moved the United States toward having liberty, as we understand it, under a regulated constitutional republic, and free enterprise, as we understand it, in a regulated market economy into space. And in general, I believe that is the way the future is going to go for the United States. That is not true of Europe, it is not true for Russia, and it is not true for China. Okay, I can tell you that there is a informed consent regime. You can go into space if you're willing to say, yes, I will accept the risk. American citizens need a launch license unless it's for NASA or the US government. Okay, so we're not where we want to be. We're not where we're going to be, but we're not where we were yesterday. Now, that's the big, gee whiz, isn't it wonderful? That's the history, that's the situational awareness. I'd like to go now to some specifics and some aspirational dreams of the future that are fully justified, in my opinion, by the current trends that we've just been discussing. Well, first of all, if you do something with private money, it only costs 10% of what it costs if you pay for it with government money. Doesn't that sound impossible? Well, let's look at an example. This is an audited by the Defense Contract Audit Agency set of numbers for SpaceX. The NASA budget model predicted that SpaceX Falcon 9 would cost $3.5 billion. And they have pretty good accounting tools for government programs. But by the time SpaceX had flown 2 missions up to the International Space Station, the total cost was under $300 million. Now, I should mention that SpaceX, before it ever flew anything, had gotten a fixed price contract for about $1.8 billion, payable only on performance. So it was less than half of what NASA thought it would cost. And instead, they brought the program in for 10% of what NASA thought it would cost. Therefore, they had some very pleasant government checks come in as they made 20 supply mission flights to the International Space Station. And then, of course, at that time, any aerospace engineer in the world would have told you it was completely impossible to land the first stage of a large rocket under power. But as we know, SpaceX has now done that almost 100 times. And if they failed now, it would be major news, but certainly not if they succeeded. Now, what did NASA invest in commercial space activities? Here are the programs that NASA invested in through 2016. During the decade, from 2006 to 2016, NASA put about $5.5 billion into commercial contracts that were, they're not cost plus contracts, they're fixed price contracts, and they gave the money to SpaceX, to Orbital Sciences, to Boeing, to Blue Origin, to Sierra Nevada, to ULA, United Launch Alliance, and to Paragon Systems. But most of the money went to SpaceX, Orbital, and Boeing. And the interesting thing is that this was only about 5% of NASA's budget during that decade. Remember, NASA's budget was $20 billion a year, and here they put about $5 billion, so they had $100 billion over a decade, $200 billion. The amount of money that they put into commercial space activities was down in the noise. It was a rounding error on some of their stuff. Now I'm exaggerating, but it was only a few percent of their budget. And for that, they got the Orbital Sciences, now Northrop vehicle, and the Cygnus capsule, which has made numerous flights to the space station carrying supplies. They got the SpaceX unmanned cargo carrier, the SpaceX manned crew carrier, and the Falcon 9 and the Falcon Heavy, even though they didn't pay for all of that. You can argue that they did because SpaceX made a lot of profit on this. And it was only about 5% of NASA's budget or less. So you have to ask yourself the question, why did they ever contract any other way? And the current thinking, in my opinion, in Washington is that although we have to maintain a national security capability and have multiple providers of traditional aerospace companies and new aerospace companies, that the contracting method of contracting at a fixed price allows such an enormous savings, sometimes up to 90% of government funds. It allows you to stretch your budget much further and get more capability. And there's always competition for budget money, and good competition, like taking care of COVID, making all the other payments that governments must make. So if NASA can do more with less by a new form of contracting, they should do that. Of course, this has to be regulated, and there's no doubt that it's so important to the future that there will be many turf battles over it. But I see the direction being in the direction of more commercial fixed price contracts. We'll see how it goes. Okay, now, so we're in the dawn of the industrial space, entrepreneurial space age. And this is a chart. I don't remember where I got it, probably The Economist. And 412 companies had received about $15 billion in equity investment as of whenever this chart was done, which was 2018. I don't know if you can see this in the curve, but it's exponential. It's not a linear curve. And since 2018, 2019, 2020, and the beginning of 2021, this curve has become steeper. That is that if you made this into an equation, the first derivative would be positive. And the number of venture funds investing in space is also increasing. And as people learn more about it, it becomes a more acceptable investment. And the number of launch companies that are trying to build launch vehicles has increased enormously. There are over 100 companies in the world today that have either succeeded or are trying to build launch vehicles. The United States has 6 manned space programs that are commercial now, 6. Okay, and some of them are space planes, some of them are rockets. I don't understand how a balloon can get in there, but I didn't do I didn't make these charts. And I want you to keep something in mind. I'm a patent attorney. I'm very aware of the fact that this is all old technology. Now, it doesn't mean that it doesn't have new engineering. It doesn't mean that they're not inventions. It doesn't mean that, for example, SpaceX, by integrating and vertically integrating the entire rocket production effort, didn't save big bucks on each rocket, and then reusing them may save even more depending on the cost to refurbish. But it isn't new technology. Fire comes out of one end, the rocket goes the other way. In a way, this is the Stone Age of space, because for decades, possibly hundreds of years, we've been building things that fire from chemical fuel, causes a gas to expand, and the rocket goes in the other direction, according to the law of conservation of momentum. It's not steam engine time. It's not airplane time. It's not quantum mechanics time. It's simply Newtonian physics. Now, the only real profitable thing now is launching satellites or getting government contracts. There's only 7 people in space. Most of them are government employees, maybe all of them. There isn't anybody up there to buy anything. So we're looking back at the Earth. We're bouncing photons off the Earth, or we're looking at photons. If we're bouncing photons, we have communications. If we're looking at photons, we have observation. And then there's some other things like geolocation, your GPS systems. These are Earth-centric. In the next 10 years, the focus of space activities is going to change. It's going to become cislunar-centric. And at that point, we won't want to haul stuff off the Earth, even at very low prices. We'll want to get it from an asteroid or from the moon. It's a good general rule of thumb that a kilogram of material taken to Earth orbit costs about $10,000. Or it was true until SpaceX. With SpaceX, if you buy the whole rocket, it's, I think, 22 metric tons to orbit, and it costs about $60 million. And so as a result, it's about, I don't know, $2,800 a kilogram, something like that. And when it starts being competitive with the New Glenn and possibly with others, it's going to get cheaper. And then at some point, we'll build a space elevator, and it'll be the cost of electricity, which will bring, it'll exponentially take the amount of material into space up by probably 10 to the 4th, 10 to the 5th. So it'll be 10,000 to 100,000 times as much mass, and the price will drop to a few dollars a kilogram. That makes resource recovery from space very reasonable, and it makes settlement of space at least possible. And it's still not a game-changing, it is game-changing, but it's not paradigm shifting because we know how to do it. We just have to do more work on the strength of materials. Arthur C. Clarke one time said that they'll build a space elevator 20 years after they stop laughing about it. Well, I can tell you they've stopped laughing about it. There is a space elevator consortium that's led by Dr. Peter Swan that has published 2 books. The Heinlein Trust helped publish them. And they have major web presence that explains every bit of this, and it's all in the public domain, and you can learn about it just by clicking on Space Elevator Consortium and watching the videos. We're much closer to this technology than people realize. At any rate, the market forecast isn't really as strong as we would hope it would be, but it's still clearly upward. And the real money appears to be in low to medium orbit communication satellites. And there's going to be a food fight about that between the traditional communications companies and the new companies. They're going to do, and it just, once that internet backbone is lifted into space and it's not running on fiber optics anymore, it's going to simply, there will not be a market for any more than there's a market now for buggy whips in our cars. So you can expect to see major political and legal maneuvering to try to stop SpaceX, unfortunately. On the other hand, you'll also see that there's at least 5 different consortia that are well-funded that are building these medium orbit communication clusters, constellations. And one of those is the People's Republic of China. They're going to build their own internet. They're going to build their own medium orbit constellation of low latency, high speed communication satellites for the internet. Okay, now I'm back to the presentations that were shown to me, which I just photographed with my camera in Luxembourg. 6,000 small satellites projected to launch by 2026. Remember, this was a presentation that was made in the late November of 2019. And I think anybody that's been following anything knows that we're going to exceed that number of satellites by 2026. We'll probably exceed that number of satellites by 2023. So all of these projections are very economically conservative, using existing technology and not taking into account fundamental changes, that is to say disruptive changes in basic physics and mathematics that allow you to do things that people now think are impossible. I'd go so far as to say that it's not thought to be generally impossible. It's not going to be a major change. It's just you're doing something better. You know, the Roman legions get bicycles to move around faster. That would be interesting. At any rate, this is the UAE. This is Dubai, the UAE Space Agency. They sent a probe to Mars. These are the people whose ancestors kept Christopher Columbus from going east, forcing him to go west, which resulted in all the things we talked about earlier. They are extremely good, careful people, and they have every possibility of succeeding fabulously. Remember, when England rose up and became a commercial seafaring power, England was a third-rate European power. They didn't really have an army. They didn't have a navy. They had to issue letters of marque and reprisal to get ships. It was a miracle that they weren't ravaged by the Spanish Armada in 1588. The UAE could be the major player on the moon. Now, this is the cheapest heavy lift rocket in the world. And it's worked successfully twice. And in one case, the boosters, all three of the first stage boosters came back. You know what it is. It's the Falcon Heavy. And what did it do on its first flight? It threw a Tesla out to the orbit of Mars. Now, let me tell you the difference, as I understand it, between the Falcon Heavy and the SLS launch vehicle that we're spending a lot of government money on. The SLS has a much hotter upper stage. That means that its C3, its characteristic velocity, is about 5 times that of the Falcon Heavy. The Falcon Heavy was only capable of throwing a car, and the battery pack had been taken out, by the way, so that's the heaviest part, to Mars. The SLS can throw a good instrumented robot anywhere in the solar system. And in fact, it's even possible with the SLS to do a precursor interstellar mission. I'll leave you all to figure out the physics. Everybody in this audience is scientifically literate. Just do the math. So although the SLS is extremely expensive and might cost $1 billion a launch, it actually has utility as an outer planets and precursor interstellar launch vehicle. It is more difficult to justify the cost of the SLS for cislunar operations, particularly as the New Glenn and the Starship become operational. And of course, if you refuel the Starship in low Earth orbit by flying a tanker flight to it, then the Starship beats everything in the world. It can take a large number of people and supplies to either the moon or Mars. And this just shows that both of those boosters, these are the two boosters landing from the Falcon Heavy. I thought it was a beautiful picture. And here is the expensive puppy, and it does have utility, and it is a useful vehicle. It is, however, far too expensive. And as time passes, just as we retired the shuttle, we'll retire this vehicle. And if the curve of progress accelerates the way it has recently, this vehicle may be retired after only a few flights. Now, so that's the American side of things. There are other American projects we'll get to in a minute, but this is the Russian hope for the future. This is the Angara 5, and it's a relatively heavy lift launch vehicle with a very large shroud. It launches from the Vostochny Cosmodrome in Kamchatka, Russia, and it is a good vehicle. The Russians really know how to build launch vehicles. And I expect that this vehicle will be commercial, and that down the road, the first stage will be recoverable. It may not be recovered under power. It may be recovered by a ballistic reentry. But the Russians are very good engineers, and don't count them out. Even if it's only 100 million Russians now, they've got the capability to have a major space program and a major commercial space program. Remember who took up the first space tourists? It was the Russians. And NASA didn't want anything to do with it. As a matter of fact, the first space tourist, Titov, and 2 Russian cosmonauts showed up at the front gate of the Johnson Space Center, and the management there wouldn't let them in. And they finally worked out a compromise on that, and the Russians made some money, and they needed it. So I have great hopes for the Russian space program. If you're out between the Earth and the Moon, or on the way to Mars, or on any other mission in the solar system, and you run into trouble, and you're going to die, you better hope that the Chinese and the Russians have a robust space program. We need powerful friends in space, because otherwise a lot of people are going to die. Now this is the Long March 7. This is the I don't remember what its launch capability is, but it's probably right up there with the Angara 5 or the Falcon Heavy, less than the Falcon Heavy. This is the Chinese vehicle. It's operational. It's flown a couple of times. It had one problem, like all new rockets have. But the Chinese have the capacity to build 10,000 of these things if they want to. Chinese space program's always been very low on money and very smart on engineering. I inspected the production facility for these rockets, for the Long March rockets, at the Academy of Launch Vehicle Academy. I forget the exact technical name, but it's the place where they build the rockets in China. And I noticed on the wall that there were plaques in Chinese, so I asked what they were. And they told me, oh, that's every person whose hands touched the rocket, pledging that they have done the very best they could possibly do to build the rocket so it will work without a problem. And they put those brass plaques up on the wall for everybody to see while they're building the rocket. Now that, to me, it said to me that their rockets are going to be very good. And in fact, the Long March family of rockets has been one of the, if not the most successful families of rockets in history. And here is the Long March 9. Now, the Long March 9 can lift 3 times the mass to orbit, if they build it, of the Long March 7. So it's up there at 140 tons, which is, it's a Starship equivalent. I don't know that they'll ever build this. They've announced that they will. But I think what they're going to do is they're going to build a Starship. They're going to build something that's 100% reusable and that can scale to get even bigger. And remember, Jeff Bezos has said that the New Glenn at 50 tons is the smallest rocket he'll ever build for orbital use, which presumes he'll build larger ones. Okay, So here's what we're looking at. The New Glenn, 45 tons. Falcon Heavy, 30 tons. Now it says 30 tons, but that's because they're not cross-feeding the fuel tanks on the test flights. I think it gets up to about 45 tons if they densify the propellant and cross-feed. The Delta Heavy, which is 28 tons. Now this Delta Heavy is the only really large launch vehicle that runs on liquid oxygen and liquid hydrogen. So it has a very high specific impulse. And it also cost $400 million. It launched the Parker Solar Probe down to the sun. It's the only rocket that could. Solar probe's about the size of a Volkswagen. And an amazingly expensive and extremely sophisticated rocket, but we're not going to use a whole lot of these because they're not reusable. And then there's the Vulcan at 27 tons. I think that's the one that's being built by Boeing, where they chop the engines off and bring them back with parachutes. And the Omega, and I've frankly forgotten what the Omega is. Let's look at another group of rockets that gives us capacity for the future commercially. Well, if the Long March 9 is still, I put Energia in there to show you the size of a 100-ton rocket. The space shuttle is roughly 100-ton launch rocket. The Energia only made one flight, but boy, it was an automatic flight. How cool. The SLS Block 1, the N1 is the failed Russian moon rocket, the Saturn V, the SLS Cargo, and then the big Falcon rocket. All I can tell you is we have a lot of capability, and I'm sure that these plans are being modified even as we talk. And here, of course, is the Starship and the Super Heavy launch vehicle, which I think are very serious, and they're going to launch from Texas. Just another nice slide. And here it is in 2019 being put together. You know the history. They've finally taken one up to a few miles and brought it back down under power and landed it. Now, why is that important? It's because they can build lots of them. If you build one Starship, you can build 100 Starships. If you build one Falcon Heavy, you can build 100. And so how many jet airplanes do we build? Well, as of 2019, we built 906 777s, and they would carry about 50 metric tons or 400 passengers, and their range was about 14,000 kilometers. So what happens when you have 906 Starships or 906 Falcon Heavies, and they're commercial? Well, we only built a couple of them then, 3 test articles. I think they're up to test article 15 now, but they left a couple out. Now, if these things can really be made commercially to fly point to point anywhere on Earth in under an hour, that's a capital market that's never been available to SpaceX before. And if it's as safe as a regular commercial jetliner, I don't think anybody will ever want to sit on a commercial jetliner for 15 to 17 hours to get point to point on the Earth. Everybody knows this, but it has economic consequences. And it's just some more pretty pictures on the moon, on Mars. And you can see that the thinking here, these are SpaceX pictures. I think they are anyway. They're not thinking about just building one of these things. The idea is to build hundreds of them, just like you would a commercial jet. And I think the entire design has been optimized to let you do that very cheaply. So now we move into the exciting part of the presentation. I have 20 minutes left to take and convince you about the future and to share with you my vision of the future based on the working in the American space program for a lot of years. I was the founding lawyer for Spacehab that flew the commercial module for the first privately built and entirely privately financed space mission. That was the Conestoga in 1982. It was suborbital, but it went into space, 250 miles. And also founded the first company to buy Russian rockets. And I've worked with the Russian space program for 20 years and with the Chinese space program for 10 years. And I haven't been arrested yet for espionage, which is good. You have to be very careful about that. Now we're going to move into the area of what is going to happen in the future. And two guiding thoughts, one by Clark and one by Heinlein. Any sufficiently advanced technology, indistinguishable, that's such a wonderful quote, indistinguishable from magic. So it's impossible, it's magic, but it changes everything. And secondly, one man's magic is another man's engineering. That's Heinlein. Okay, I'm going to give you a couple of examples. I can give you these examples even though they're my clients as a patent attorney because I have their permission. This is a way to mine the moon without putting a base on the moon. If you have to go and land on the lunar surface with a spaceship, you have to have about a 1.5 kilometer per second cost to land and about another 1.5 kilometer per second cost to take off. That's 3 kilometers per second. It's about 1/3 of what it takes to get into Earth orbit. It's really expensive. You have to have a dedicated lander that can do both jobs. Now, you may have to do that some, but there's a better way. And that better way is to use a tether. A tether is a little space elevator. You take and you put a spacecraft, an orbiter, into lunar orbit. It's generally lunar polar orbit. And it's very special orbit. They're called frozen orbits. And it's beyond the scope of this talk to talk about the celestial mechanics, but there are some orbits that are stable around the moon. And then you take and you put a rotating platform with a long tether on it, where the tether comes down to within just a few hundred meters of the surface of the moon. And then you put a little tether on the lower platform, which is like a working platform on an oil rig, and you drop a penetrator with a tether on it, and you pull up your sample. For the next few years, most of the money is going to be spent on getting samples back from the moon. And this can take hundreds of samples in the time that a landing system would take a few samples and much cheaper. You also, by adjusting the lengths of the tethers and some tricky control electronics, can lower the impact rate to where you could land people or supplies anywhere on the moon, or you could move material from one part of the moon to the other. And if anybody is interested in this, they should look up Zodiac Planetary Services. And I think they have a website. I think they have finally gotten enough money for a website. But it's a good invention, and the patent is still pending. This is a core sampler, but there's no reason you couldn't scale this up to mine ice. So if you can pull up hundreds of tons of ice from the moon without having to build landing systems to carry it off the surface of the moon, that would be useful. Also, the momentum transfer in this can be done by electric engines, super high specific impulse electric engines like the Vasimir engine now being built in Houston. Okay, this is my company, Excalibur Almaz. This is a quantum mechanical space drive that nobody has been able to poke holes in the math or physics yet, and we're raising money now. I'm not trying to raise any money. I'm just saying that we're going to be building a prototype of this. It works by moving a conductive position in space at near the speed of light. The physics on this is well established. It is the dynamic Casimir effect. I think that this is online. If it's not, we'll put it online at the Excalibur Almaz website. But the interesting thing is that it's not a small effect. The effect is thousands of newtons per square meter. And it's basically magic. In other words, it cannot be intuitively predicted. from Newtonian physics. It is quantum mechanical. But you're welcome to look at this more. I presume that the people in the conference will put all of this presentation up online. Now, that leads me to my prediction about the future. I don't think that future ships launching from the Earth or from cislunar space to carry humanity to the solar system and then to the stars are going to look anything like ships do now, any more than a 747 looks like a balloon that's being pulled by geese, which in the 16th and 15th century, any flight to the moon that was hypothesized, it had a balloon and a bunch of geese pulling it. I think it's going to look more like these super liners that carry thousands of people. This is the Cunard liners, Queen Mary, Queen Victoria, and Queen Elizabeth. They are super comfortable, they are super luxurious, and they go around the world for months with thousands of passengers. And this is what you will take to the moon in 20 or 30 years, something like this. Now, if we have to depend on rockets, it's going to be expensive. If we get quantum space drives of any kind, and there are a dozen of them that are being looked at, we are way down on the learning curve on how to get momentum out of the electromagnetic ground state. Let's just say that the future will be a little different than we expect. So where are we now? Where are we going? What could we do with space research? What's possible? Okay, right now, we need about 5 planets to let everybody have the same level of material affluence that exists in the United States. That's the bottom line. Everybody would like to live better. It's reasonable that anybody would like to live better. And if you live like people do on the average in the United States, you got to have 5 planets worth of resources. This is where they are. We know where they are. They're the asteroids. There's the main asteroid belt. There's a few asteroids that cross the orbit of the Earth that are easy to get to. They have less energy to get to them than to get to the surface of the moon. We may mine those first. They're easy. Then there's the main asteroid belt. But there are more asteroids in the Trojans than there may be in the main belt. And then finally, we have the Kuiper belt and the Oort cloud, which if we mine them, we've got billions of times more material than we have on the Earth. And we're discovering more asteroids all the time. This is a great time, by the way, to get an asteroid named after yourself. Let me see if this thing will run. It won't run. Of the near-Earth asteroids, the ones we will go to probably first to explore, to learn how to develop the technology and the engineering to do space mining, to determine what we can do with robots, what we can do with people, and what we can do with people and robots. This is the wealth of the future. And this is the furthest one out we have a picture of. This is, I don't remember what they named it, but this is what New Horizons went to after it went to Pluto. And there is enough material in that very far out Kuiper belt object. You can probably see it's a contact binary. For possibly millions of people to live on it. Now, I realize I'm talking science fiction now, but hey, this is a conference for people who like science fiction. This is a comet, I think, that the Europeans went to. Point is, there's enough material in this for 1 million people to live. Now, one small asteroid would provide enough metal for decades for the Earth. It would also provide the potential for a space program 10,000 times larger. In fact, at that point, you're talking about moving civilization off the Earth. This is what Bezos is talking about. Millions of people in space, lifting the industrial infrastructure into orbit, using artificial intelligence and additive manufacturing, essentially to reduce the cost of capital goods radically. Now, we've seen this happen before with computers. Originally, the computer cost $100 and the software cost $1,000, or the other way around. The computer cost $1,000, the software cost less. IBM would give you the software if you bought their computer. And what Bill Gates did was to realize that he didn't have a way to build computers really. So he built the software and presumed that the computers were free. And now computers practically are free. I mean, at the performance per cost curve, the cost of the hardware is very close to zero, and much of the software is very close to zero. And it changed everything. We're growing a nervous system for the human race. And we're only partway there because there's 5 billion people that aren't connected to the internet. And that's the market that all these low Earth orbit constellations are going after. But once that happens, and there's tens of billions or hundreds of billions or trillions of dollars in space industry, we're going to go after everything else. Because who wants to have a blast furnace in their living room? Why make steel on Earth if you can make it into a park? And Bezos makes this very well, and so does Musk. And I think everybody that looks at the economics of the future thinks that it's realistic. Okay, so I did take one asteroid and looked at the value of it. This is only a 2-kilometer asteroid, and this is old data. It's from 1994. But just the nickel, and by the way, the market for nickel is robust enough on the Earth. Only about 1 billion people use products that are made with a lot of nickel because they're stainless steels and specialty alloys. But inside of a decade or two, 5 billion people will. So there's a huge growth curve, and it's so expensive at tens of thousands of dollars per ton that we recycle 85% of nickel now. So nickel will definitely pay off. If you dump that much platinum on the market, the cost of platinum will be ruined. But the whole U.S. debt of $15 trillion back then could easily be covered by this 2-kilometer asteroid. So this is the talk that I give when I'm talking to people who don't have any idea. I'm sure everybody listening to this already knows all of this, but I want to quantify it for you. Okay, now, this is a photograph. A lot of people in my office think it's a painting, but no, it's a photograph taken by the joint NASA-ESA probe that went out to Saturn and dropped a lander onto Titan, the moon of Saturn that has an atmosphere. It's a beautiful picture because Saturn is backlit and the rings are illuminated. But if you look at it very carefully, you will see a tiny dot. Let's see if I can show you the dot. There's the dot right there. You see that dot? That's a very tiny dot. And that dot is the Earth. If we don't go into space, if we don't settle the solar system, if we don't set our sights on being an interstellar adventurers very shortly, all we and our children will ever have is that dot. If you want that to happen, you can just turn off your computer now, because the rest of this talk for the next 5 minutes is not going to be interesting to you. But if you're with me and you think that this is just a pale blue dot seen by a Japanese spacecraft over the lunar horizon, by the way, the moon is that color, it's the color coal. We have all of these elements, they're all on the moon, all of them. There's a book that you can get from Amazon or anywhere you want that's a International Academy of Astronautics study. I was the editor of it, along with the head of the Chinese Space Society. That's a desk encyclopedia of all of this stuff, and it includes business plans from 5 companies. And we translated it into Chinese, and it was published by the Chinese Astronautics Publishing Company. And by the way, just to give you an idea of how big the moon is, you could put 1,500,000,000 people on the moon using the resources of just its surface. They'd be perfectly okay. Now, it would take time and it would cost money, but there's no physical reason it can't be done. So where do you want your grandchildren to be at the end of this century? Do you want them to be just on the Earth, or would you like to have all of these other planets? That is the choice that you have to make and that you have to convince other people about. But I can tell you that the resources of our solar system are effectively infinite. The mineral wealth of just 50 asteroids, we know where they are, we know pretty much what they're made out of, would be enough to support a space civilization in the solar system of more than 10 trillion people. That's hundreds of times more than are alive now. And that's at a gross national product per capita of twice the United States. All I can tell you is that the future is there, and we're going to have an awful lot of fun getting there. So personally, I want to go up there and do a little bit of prospecting and hopefully getting some resources. I'd like my children and grandchildren to take and sell the solar system. And it's just a matter of doing it. So thank you very much. I appreciate your attention. If you have any questions for me, this is my personal email. It comes to me, not to my office. And you can ask them. Okay, I'm out of time. I appreciate your attention. And again, thanks.